Okay, so today we will move to chapter 5 for mechanics, connecting particles. So for this chapter we will apply the Newton's third law, right, to calculate the main thing is the tension or compression between the particles and also the acceleration for the system, right. So we will apply Newton's third law. Newton's third law say that for every action there is an equal and opposite reaction. This means in every induction there is a pair of forces that have the same magnitude but act in the opposite direction. So means let's say I uh, I try to use my hand to punch someone's face, right? So if I use let's say 10 Newton in my palms, okay, and I punch on a person face, right? So and at the same time the person face will apply 10 Newton to me also. So this is the uh, what mentioned in the Newton's third law. So if I use 10 Newton to his face, and his face also apply the 10 Newton to my head also, right? So in this situation, like both also accept the will accept the 10 Newton on a different direction, right? So this one we call Newton's third law, right? The simple example. So for this chapter, we will study something that connecting the particles. Normally connecting the particles, we will have an inextensible string, maybe a couple, or inextensible wire, something like that. So in the syllabus of paper 4, we will not consider any extension of the connecting components, right? So we always assume that the things that connect two particles is always is a solid body. It will not deform, right? It will not deform, either extension or compression, right? We assume it's a solid body between the particles, right? So so these chapters, a lot of question, right, you will need some logical thinking, right? So there are the question that tell you that after a while the system already running, right? And let's say you have two particles, right, connecting by a cable, and the center have pulley. Okay, so the heavier particles will go down, lighter will go up, right? So in a one system they have the same acceleration, right, but maybe in a different direction. So before the item reach to the pulley, right, if the wire this wire is in tension, right, so they will move in the same A, right? But there are a situation after a while, let's say the same system, the item touch on the ground, right, and the the cable become loose, right? So this item will move with a free body, right? So this item will not affect by the connection of the item. So after this item touch on the ground, this cable become loose. So this on the ground, and this item B will be moved like a free flow body, right? So after the thing touch on the ground, this will be have a individual movement already. So no more connection between these two particles between A and B, right? So this kind of question will always ask in your exam lah. So you need to have some logical thinking, okay? Originally, normally when the cable is in tension, they will move in one system. So the A is the same. After the thing touch on the ground, or maybe breaking of the cable, so what happened to the system? So this kind of common sense and logical thinking, then you have to build by, I mean, you visit a lot of question, you did a lot of question, then your skill in this part will be better, right? Although you're not going to have exam for paper 4, but this kind of knowledge you will bring over to further mechanics, right? So study well in these chapters, right? So you may use this, you may use it, okay? And you will proceed to example 1 now, okay? Right. Okay, example 1. A car towing a trailer travels along a horizontal straight road. The car has a mass 1500 kg and the trailer has a mass 500 kg, and the resistance of motion is 80 newton and the car have 20 newton on the trailer. The driving force produced by the engine, okay, engine car is 360 newton. Find the tension in the tow bar, right? So you can draw, normally we will draw a diagram. Okay, the first, okay, this is the car, right? So you have a 360, okay. Don't forget you have a resistance SPI 80, and you connect by a tow bar, so you have a tension here. Assume it's a tension, okay. We do not know, maybe it's a compression, we didn't know, just assume a tension. So at the behind here, you opposite direction you also have a tension, okay, pulled by the car. And don't forget you have an opposite direction of 20 newton, the resistance, okay. So you have, actually this is a one system, right? So you have two components, right? One is the car and one is the trailer, right? So we separate them by two sides. Okay, for the trailer we can form an equation. Let's say we go to the right hand side, is a positive, so T minus 20 is equal to the weight of the trailer is 580. Okay, your net force equation. Okay, so and if you proceed, you have the first equation on this side, and another side you can form another equation. 360 minus 80 minus T is equal to 15008, right? Don't forget the A, their A are same, it's the same item A, right? The tension is the same, so you have two equation, okay. So you can solve it simultaneously. Either you put you want to use which side to sub in another side is no issue. So solve it simultaneously. You may able to get that T is equal to 85 newton and A is equal to 0.13, right, meter per second square. Okay, so how you want to solve, no issue, right? You can solve it simultaneously. Some students may think that you can use it another way to calculate the acceleration first. Actually, let's say, okay, so you get T and A. Another method, you can get the A by consider the total system, right? Let's see how to consider the total system. Okay, I remove this part first. Erase. Okay. Okay, so let's say we consider this is a total system. The total weight of the two items will be equal to, total weight will be total mass will be 1500 plus 500, right? Okay, and you have a driving force 360, right? We just consider the external force, and you have two resistance for each item. Each item you have one, you have 80 and 20 behind. Okay, so when you have these two, you can consider this is a total system. So you have 360 minus 100, okay, is equal to 2000 A. Okay, so by solving this, you will get A equal to 0.13. Okay, so this is a similar solution to the previous part lah. But if you want to find T, you have no choice. You have to separate the system by two parts. Okay, so this is for example one. Okay,